Okay, we're going to be looking at some of the fundamentals behind electric potential energy difference and electric potential difference. As in previous videos, to get the best out of it, if I ask a question or ask you to do a calculation, stop the video or pause it, try your hand at it, and then restart the video. Okay, I show a uniform constant electric field, the positive x direction and the positive y direction. And E is just simply the magnitude of E times I hat, then the unit vector for the x direction. Okay, first question is, what is the relationship between the electric field and the electric potential energy difference experienced when a charge moves from the force of the electric field? Go ahead and write down what equation you believe states that relation. Okay, we have that change in potential energy is equal to minus the charge times the integral of E dot ds, where ds is in the direction of movement and E represents the electric field. If the charge accelerates in the electric field in the x direction, what is the potential energy difference? And that is given by the change in potential energy equal to minus q, the integral E I hat dot dx I hat, which is simply minus QE integral dx. From 1, identify the electric potential difference. If you look at that integral, what part of the integral represents the electric potential difference? And of course, it is that delta U equal Q quantity minus the integral E dot ds. And that is our electric potential difference, equal to minus the integral E dot ds. Now suppose I move the charge Q, which we'll take as positive, from A to B. What is the change in the potential energy? Pause the video, work it out for yourself, then restart the video. Of course, it's that the change in potential energy is equal to minus the integral from A to B integral E I hat dot dx, and there should be I hat there, equal to minus Q E quantity B minus A, and that quantity is positive, and answers the next question. Show that the change in electric potential difference is positive also. And we have that the change in electric potential is equal to minus the integral of A to B E I hat dot ds I hat, which will be in the dx direction, equal to minus E quantity B minus A, which is also positive. Now suppose that the charge is a negative charge. Show that delta U is less than 0. That is negative this time. For Q in 4, simply substitute minus Q. And you can see at the end of the calculation that if I substitute a minus Q, I have a minus times a minus Q, and then the quantity will be less than 0. Why isn't the electric potential difference negative? There's no charge. Notice that in 6, there is no charge. The sign stays exactly the same. regardless of whether I use a positive charge or negative charge. So the electric potential difference stays the same, even though the electric potential energy differs according to whether it's a positive or negative charge. End of problem.